Hi everyone, I'm Abhisheka. Now I will talk about our project Predictive Analysis of Stock Market Trends using the machine learning approach that is LST. Analyzing financial market is a challenging job due to their complexity, volatility, and susceptibility to an unexpected event, and traditional forecasting methods based on statistical analysis and the historical data often fall short in such a dynamic environment. This has led to an adaptation of advanced machine learning technique, particularly long short-term memory. LSTMs are well suited for the stock market prediction because they can effectively model the short dependencies patterns, much like those observed in the time series data. By extending the recurrent neural network, neural LSTMs provide a powerful tool for forecasting and predicting of stock market prices. Problem with the recurrent neural network is a vanishing gradient, where it forgets the previous weights. LSTM overcome these problems by selective remembering. The problem statement of our project: stock market prediction is a complex task influenced by the dynamic factors and the intrinsic relationship that traditional financial models often fails to capture. This project addresses these challenges and utilizing the long short-term memory neural network, an advanced variant of recurrent neural network capable of modeling long-term dependencies and the complex patterns in the sequential data. Next will be continued by Gajanana.
Hi, my name is Gajanana. Algorithm design. Step 1, data collection. In our project, we have used API key known as have finance instead of dataset because in our project it requires a dynamic data. That's why we have used API key for data collection. In step 2, pre-processing. As the dataset contains various anomalies, to prevent that one, we have used different techniques to handle missing data. We will drop that type of data and apply min max scaling to normalize values between 0 to 1. Step step 3, model design. No, we have used LSTM instead of RNN because LSTM is suitable for our project. The LSTM is more convenient for dynamic data. LSTM will carry the prioritized data, but the RNN will leave that previous data. That's why we have used LSTM in our project. Training the model. Step 4, training the model. Data split. We have splitted the data in the ratio of 80 is to 20, that is training data and testing data. Epochs, number of complete pass through the data. No, we have also implemented the mean squared error MSE to predict the predict to gauge the predicted error prediction error. Step 5, prediction and visualization. In our main aim is to predict the user stock in next 50 days, how it will be in next 50 days. Not only the prediction, for user, for to make it user friendly, we have implemented in visualization. It will along with predicting, it will visualize in various graphs and like scandals and all. Step 6, deployment. We have hosted this in local host using a Streamlit app. User want to enter the stock ticker to predict the to use our application. Further will be continued by Deepak.
Hi, my name is Deepak S Angadi. On this slide, we will cover efficiency of our model and how we handle key functional requirements. First, efficiency in terms of time and space. Time efficiency. Min-max scaling reduces computation time. We significantly reduced computation time by implementing min-max scaling. This normalizes data into consistent range, making calculation faster for this model. The core of our model, the LSTM, is inherently designed to handle sequential data like stock prices more efficiently than traditional machine learning, and early stopping and dropout prevention training. We also implemented early stopping during the training phase. This technique automatically stops the training process once the model's performance stops improving, which saves our valuable time and prevents overfitting. Next, For space efficiency, when we save our train module, the parameters are stored in lightweight .h5 format. It is hierarchical data sequential format. We also optimize the length of our training data sequence to ensure they are long enough to capture the trends, but not so long that they consume excessive memory. In this slide, we cover functional requirements and edge cases. Beyond efficiency, our design successfully meets all the core functional requirements we set out to achieve. The system can predict both short-term and long-term stock trends. It provides clear visualization like graphs and helps user to interpret the results easily. And based on the predicted trends, it offers a simple recommendation to buy, sell, or hold. Finally, we have also encountered for potential edge cases. If a user enters an invalid stock, the system returns a clear error message instead of crashing. If there is a insufficient historical data for a particular stock, we have fallback mechanism to handle it gracefully. And to manage sudden extreme market spikes, we use moving average smoothing to focus on the underlying trend. Further will be continued by Afrid R.
Hi, I am Afrid R Correctness and validation. Our project produces correct output for test cases, which actually model tested on multiple stocks like Tesla, Apple, NEC, BSC companies, and others like MRF also. And the results graph shows the close alignment between the actual and predicted prices of the stock market and forecasted next 50 days, which actually suggests the customer to buy and sell the stock. And the proper validation and error handling. Validation. Our model train and test split ensures model generalizes well, and it splits the model data sets into train and tested, and it generalizes the all data sets. And performance metrics. These are the performance metrics which are used in our project. R square score 0.89, close to perfect fit, and it actually used for the graph measurement. And the cross validation score, which is 0.84, stable performance. And MSC, that measures the average error in the project. And the error handling prevents the divide by zero in scaling. And the demonstration correctness with examples or proofs. The result graphs actually showcase the actual versus predicted graph of the stock market prices, which shows the overlap between the both actual and predicted stock prices. And the next 50-day forecast curve, which shows how can customer actually sell and buy the uh, stock in a stock market. And the moving average smoothing curve. And next, recommendation output, which actually suggests the customer to buy or sell or hold based on predicted trend. And P bar E ratio analysis. And the proof of correctness, which actually matches the trends from research paper and the works consistently across different companies as like MRF and others also. And these are the result images from our project, which actually shows the predictive analysis of stock market trends from various days. And this is the prediction versus original graph and the closing price versus time chart with 365 days. These are the reference we used in our project. Thank you.
Now we will see the demonstration of our project, Predictive Analysis of Stock Market Trends, which is built using LSTM and deployed using Streamlit. The user enter the stock ticker as an input for the model, like the MRF.NS. And the system fetches historical data from the Yahoo Finance. It then displays the past trends in a chart and uses our LSTM model to predict the prices. The result showed in actual versus predicted, where the predicted values closely follows the real prices, providing the accuracy of our model. We also provide future forecasting of next 50 days, which helps the investors to understand upcoming trends. Finally, the system give buy, sell, or hold recommendation based on the predicted performance. The next 5 year recommendations and the returns will be displayed. Thank you.